Hello everyone. Today we will see another example of mathematical induction. You had it as your fourth assignment, and the solution was actually in the book. You could find it as example number 9 in the main textbook. But anyway, let's go through it in detail to see how we can solve such questions. So, use mathematical induction to prove that this proposition is divisible by 57 for every non-negative integer n. Non-negative integer, it means that 0, 1, 2, 3 until infinity. So there are two ways to deal with that. First thing is that to show this is false, this is not true. In order to show that this is not true, you should find a counterexample. So how can we find that? From 0 to infinity, 0, 1, 2, 3, if you find any integer that if you assign to this variable n, then you find out that this is not divisible by 57, then the solution is over. You say, by counterexample, I showed that this proposition is false. But if you want to show that the proposition is true, which it is in this case, then we should go through these two steps as induction steps. We call them basis step and inductive step, as we talked about it in our lecture. So the first step is to start from our initial step and show that from the beginning at this initial point, this is true. And we already talked about non-negative integer. It means that from 0 everything starts. So we assign 0 instead of n. We will have 7 power 0 plus 2, which is 7 power 2. 0 instead of n, so we will have 8 power 1. And the summation is 57. So it's obvious that 57 is divisible by 57. So this is true. And as we said, it's not always 0, but from this question, it was clear that we are talking about non-negative integers, so it was obvious that it starts from 0. But sometimes we should check and to understand that what is my initial point. And we gave you one example in the lecture. So as soon as you show that for the basis step this is true, then you can start your inductive step. What do we do? What do we do exactly in inductive step? First of all, we show that for one arbitrary non-integer, this is true. So k instead of n, it means that k is just a number which is non-negative integer. Then we say, okay, this is divisible by 57. Let's assume that. Now, if I add one number, one unit to k, can I show that based on this assumption that this is true or not? So what do I do? I add 1 to k. So instead of n, now I will have k plus 1 here and k plus 1 here. So this is the proposition that I will have. Now, what should I do? I should somehow try to find this term inside it as a factor so that maybe I can show that this is true. Let's see. So here, I can easily find this term by just getting 7 out of this term. K plus 3, it is equal to 7 multiply 7k plus 2. This is a power. You remember, for power, if you want to add 1 to it, you should multiply 7. If you want to decrease 1, you should divide it by 7. So this is obvious that how we reach from k plus 3 to this one. So if you want to reach, for example, k, you should multiply 7 power 3 to this term. Okay, and what about this one? Why I got 8 power 2 out of it? Because I want to reach this proposition. I want to reach this term. That's why when I consider this factor, I wanted to reach this one. So What to do next? Here 8 power 2 is 64, and I already have these two terms, but they have multiplication. Now I'm also interested to show that this is divisible by 57. This is our goal here. So what should I do here? I can write 64 as 75 plus 7. If you write 64 as 57 plus 7, it means that you multiply 8 power 2k plus 1 once to 7, once to 57. So what you have here is 7 multiply this term plus 57 multiply 8 power 2k plus 1. So now you can factor 7 from this term and this term, you see, and 57 multiply 8 power 2k plus 1 is already there. So you already reached this part. Is it divisible by 57? Okay, this part of the summation, this is obvious. This is divisible by 57. And what about this one? Yes, this is our assumption. By using this assumption, we showed that for k as an arbitrary non-negative integer, this is divisible by 57. So this part of the summation is divisible by 57, this part as well. So if you factor 57 out of this and show the term, all the rest of it, then obviously the whole term here is divisible by 57. So it's pretty easy. As soon as you see the final answer, it seems very easy to see the final answer and you can solve it again and again. But what's the challenge here for mathematical induction? If I solve for you 1,000 number of mathematical induction examples and you just watch it, it seems very easy. But as soon as you want to prove a new one, maybe you need a new trick. So you may ask me, how do I understand, for example, here you use the trick here to reach 57 and you factor it out. How can I understand it? By observing a new example. Because the examples we ask you, it's not just about, for example, division. You saw in the examples in the textbook that there are a variety of them. So if you ask me how can I master this topic, my suggestion to you is to tackle as much as example as you can. And don't just watch videos about them. Just go through the examples in the textbook, and before see the solution, try to solve it yourself. And give it time. I mean, maybe after 30 minutes, you understand how to solve it for the first time. It's okay for the beginning. But after you do it again and again for variety of examples, and fortunately we have lots of them in the book, we also solve for you some of them. So I hope that you will get ready. Also for the midterm, we will have such proof for mathematical induction. And if you have any questions, of course, in the examples in the book that you had difficulty to understand, of course, you can ask me about them. So if you have any questions, please let me know. Otherwise, I will see you guys on Friday and we will talk about a new topic. And I will also talk about the midterm exam in detail on Friday.